Hello students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma and we are studying our first chapter and which is number system. Okay, so now you are very familiar with the name of your first chapter which is number system. So, what we have covered yet? We have covered numbers, specific type of numbers, rational, irrational, sets of numbers, natural, whole number, integers, and then we have covered the particular irrational numbers representing the numbers on the number line. Okay, then about the irrational numbers, we got some operations like multiplication, division, addition and subtraction of rationals and irrationals and both irrationals as numbers. And we concluded some points. What points we have concluded? That if we are talking about rationals, so rational plus rational is rational, rational minus rational is rational, rational multiply by rational is rational, rational divide by rational is rational. What we concluded about irrational and rational? Irrational plus irrational is irrational. Irrational minus irrational or irrational, rational minus irrational is what? Irrational. Irrational multiply rational is what? Irrational. Irrational divide by rational is what? Irrational. And then we have that combination of, not combination, but we are only having this irrational. Irrational plus irrational is what? Have two cases, that may be irrational also and rational also. Likewise, irrational minus irrational may be rational, may be irrational. Multiply again may be irrational, may be rational. Divide may be rational, may be irrational. That means the possibility is whether it can be rational or irrational depending on what numbers you are choosing. Okay. So, in case of rationals, two rationals always give you rational. If it is one rational and one irrational, then always irrational. But in case of two irrationals, that may be rational as well as irrational. Then we find out to perform some operations, basic operations on the irrational numbers, and we have done some questions about that and we will find out the result also. Now, we are talking about some identities. In our previous lecture, we have talked about that a root plus b root whole square, and that will be equals to, the formula will be for this a plus b plus 2 root ab, and in the case of minus, root a minus root b square, that will be a plus b minus 2 root ab. We have also discovered that root a plus root b multiply by root a minus root b will be giving you a minus b, simply. Okay. Now, these were the formulas we have covered, these are the identities we have covered in our previous lecture. Now, what about this lecture? What is new in this lecture? We are going to add some more identities here and will then do the questions over there. Okay. So, here it is. Root AB. Root AB, if I talk about root AB, how will you solve that? Root A multiply by root B. Multiply or dot, or you can just write root A root B. So, basically when I am telling you that root 15, then you can just also write it root 5 multiply by root 3, okay, and the vice versa is true. Now, this root A by B is nothing but root A by root B. Root A by root B. What is root A by root B? Simply root A by B. Okay. Then I am having this formula root A plus root B multiply by root a minus root b. So we have covered this particular formula, student, here this formula. So this formula, these three formulas have been covered. Then we are having this root a a plus root b multiply by a minus root b. So what is the formula here? A plus root b, then a minus root b. Simply as per the formula, you will be having the a square minus b square. So simply this is a square minus b. Okay. Look at the formula too. If you will open this bracket, according to a square plus b square, a square is what? This a. A square is a square simply. Now b square is what? On the place of b you have mentioned here root b. That means root b square. So root b square is only b. So a square, the first term, minus the second term. So a square minus b. Here is this value. Now if it is true, then we can also say that if I am having this value as root a plus b and root a minus b, then the value will be a minus b square. This is also true. Okay. Okay, this identity is also there. Now I am having this, correct it students, this identity, there is a plus here. Okay, so this is basically root a plus root b multiplied by root c plus root d, and that will be, I am writing it here, the identity is where it was here, root a plus root b multiply by root, or I can write it here, I can write it here this side, come, here I can say that root a plus root b root c plus root d, that will be equals to, this is the exact one, okay, that will be equals to, simply what you have to do, you have to multiply this by these two and then by this by these two. So that simply will be root a root c plus root a root d plus root b root c and then root b root d plus root b root d. Now we have mentioned it here that we can write root a root c as ac, root ac. Okay, so I can just simply write it root ac plus root ad plus root bc plus root bd, and that will be the formula for sure. So the formula is here, this will be the formula. Okay, so this is one. Now after that we are having root a plus root b whole square. Okay, so we have covered this root a plus root b whole square, that is a plus b root 2 root ab, or we can write a plus 2 root ab plus b. Okay, so now you can do one thing, just note it completely and then we will move towards the questions. Noted? Okay. These are the identities that we are going to use in our questions. Okay. So here we are with the next slide. Okay, so before doing the questions based on the identities, we are going to do one thing, which is representation of irrational number geometrically. Now we are going to study this. After that, we will move towards the questions part. The questions based on the what? The identities of irrational numbers. Okay. So, here, how will you represent something like root 2? I have told you that you will have this line, you having the 0, the 1 here, you will be having a perpendicular to it and that will be of unit length. Then you will be meeting this point to 0 and then you will be having an arc and that arc will be meeting this line, number line here and here, because it is root 2 by the trigonometry this is root 2. So, that will be also root 2 because this is the radius and this is the radius also. Okay. So, that was about root 2 and what I have told you about root 3, then you have to draw a perpendicular of unit length here and then you will be having this root 3. Now, you will be taking this arc extended to your number line and then it will be your root 3. Now, if I will tell you to draw root 7, how many times you are going to repeat this process? Is it tedious or not? It is frustrating or not? It is not a convenient method always, right, to draw irrational numbers, large irrational numbers like this. So, now what to do? Okay. There is a very simple method. What you have to do is just like okay, I have to mark root 4.5. Root 4.5 on the number line. So, what will I do? Now, look at it very carefully. Root 4.5. Okay. First, draw a line, let us say AB equals to 4.5. Okay. You have drawn a line equals to 4.5, right. Then extend this AB to a new line, to a new point, sorry, C, such that this BC is of unit length. Okay. Now what? Mark the midpoint of AC. Mark the midpoint of AC. The midpoint of AC is somewhere like there. So, by the measurements or your scale or by the help of the divider protractor, you can easily find out the midpoint of these two. You have studied in construction. Okay. So, in case you have not read it in construction, these are the 2 points. If these are the 2 points, then you have to have your pencil here, have your divider here and have an arc over there. From here you will cut an arc from the same arc. From the same arc you have cut arc here, you will be cutting arc from here. Arc length will be same, should be the same. Now, you will be repeating the process with the same length arc in the downwards direction too. Now you will meet this point to this point. Okay. Now this point, whatever this point will be your what? Perpendicular bisector. Now bisector means that this point, it is dividing this line in two equal halves. So you can have that process, same process here also, and let us suppose this is the point O. This is the point O, you got it from the geometry, right. Now what will you do? From taking center as O, and OC as your radius, you will draw a semicircle is quite not semicircle actually, but okay, mind it that it is a semicircle for you. Okay. So let it be a very good semicircle. So this is a semicircle. Now what you have to do? Draw a perpendicular on this line AC to the point B. So that will be the perpendicular. Perpendicular is there. Okay. Now it is cutting this edge here, so that will be perpendicular over there. Alright. Now you are having this perpendicular and having this as O. Now you can meet this to O. Now what? This length is basically your length root x, or what you call root 4.5. In this case that will be root 4.5. Okay. So in sum total you have created a line is equals to AB. Now just do not write root x here, put root 4.5 in this case. Now you may ask me how it is possible that we have drawn 4.5 here and will be getting root 4.5 as this length. How it is possible? Is it convenient for us to tell it? Now you can just take this some arc equals to this B and D and just put this point here and mark it on the number line. So let us suppose if it is marking here, that will be your root 4.5. How? Geometrically how? Okay. So first we are going to have some construction lines here and also will generalize this, that how this is gonna be root 4.5 when I have drawn this line AB equals to 4.5. So I am taking a generalized term x. I will be having this as x and then we will see that is this possible or not for each and every value. So let us suppose this is root x. So obviously I have drawn this as. Now first thing is what we call the construction steps. So come here this side and we will write construction steps. So here they are. Okay. First one, what we did? First we draw AB equals to x. Draw AB equals to x. Then the second one, after AB I have extended AB up to C, extend AB to point C so that BC equals to 1 unit. Understand? Now, after doing this, what we have done? We have marked this point O. We have marked this point O. Okay. So, in the step 3, mark point O such that AO equals to OC. That means O will be the center of AC. AO equals to OC. That means these are the two halves. Okay. Now, fourth one. After having that center, what I have done? I have created a semicircle. Draw a semicircle upwards taking O as center and O is the center here and OC, or you can say OA and OC or OA as radius, right? Then what else we have done? After having that as after having that as a semicircle, what we did? Draw perpendicular from point B to the semicircle. Draw a perpendicular BD on semicircle, not on semicircle, on line AC, on line AC intersecting circumference of circle, right? After that, come this side. Point number 6 is BD is equals to root x by this construction or construction. Okay. Now, these are the construction steps. Now, how these construction steps are actually true? We will find it. Okay. So, students, you are seeing this triangle OBD. Now, you have to find out that what is this root x or not. You have this as x by your construction, this have as unit length by your construction. You are having this as x by the construction. You are having this unit length by your construction. Now, you have to find out, is this root x actually or not. So, just do not assume that this is root x, just forget this is root x by the construction and just find it by the geometry or by the Pythagoras theorem. So, we can write explanation here. Then why it is so? So, by construction what we have done, we will write it here. OA equals to OC equals to OD. What is the value? We will talk about it later. First, now we have drawn this AB equals to x and BC equals to 1. Now, I am talking about OA or OC or OD. So, I am approaching this OA. This OA this OA. Okay. Now, this OA will be what? The half of the complete length AC. That means OA is half of the complete length and AC. Okay. So, that will be true for all these three. That will be AC by 2 simply. Okay. Now, what is the value of AC? Look, it is x here and it is 1 here. If it is x and 1, that means the value of AC will be x plus 1 by 2, x plus 1 by 2. This is the value of AC and this is the value of OD, OC and OA. The value will be half of x plus 1. Okay. So, now it is clear here. So, I have to look in the triangle OBD. If I am looking for the triangle OBD, I have to have the values OB here, DB here and OD here. So, by this I am having this value OD equals to x plus 1 by 2. Now, the remaining values are OB is done? No, OB is not done. So, I am having this value of OB. Now, the value of OB will be x minus AO. Listen again, value of OB will be this complete length minus this length. Okay. So, value of OB is equals to this complete x, that is AB minus AO. That will give me AB is equals to x which is given and AO, value of AO I have find out to be x plus 1 by 2. That means value of OB is equals to 2. Now, 2x minus x is x and minus 1. So, when you solve this, you will get OB equals to x minus 1 by 2. So, this is the second value I am getting. Now, this is first value, this second value. What is the third value? Third value is something we have to find out. This is BD. So, by Pythagoras theorem, what we are having, OB square equals to, or we can say BD we have to find out, or we can write BD square equals to. Okay. So, BD is what? Perpendicular. So, BD square will be equals to the hypotenuse square, that is OD square plus OD square minus the base square which is OB square. Now, I am going to just put the values of OD. So, OD's value is x plus 1 by 2 and its square, and OB's value is x minus 1 by 2 whole square. So, this is the value. Okay. That means BD square will become, I can take 2 square, that is in the denominator, 2 square will be equals to 4. So, I can take 1 by 4 common. After taking 1 by 4 common, I am having this x plus 1 whole square minus x minus 1 whole square. Okay. So, x plus 1 whole square a square plus b square minus 2ab, plus 2ab. Okay. And when I will go with this minus, so minus sign will change the entire signs of this. Okay. Or I can say, or I can just write it down again like minus a square plus b square minus 2ab. This is one. Okay. So, minus of a square plus b square minus 2 of ab. Okay. Bracket close. That means BD square will be equals to 1 by 4 multiply by x square plus 1 plus 2x minus x square minus 1 plus of 2x, sign will get changed. Okay, and now this x square will cut 1 and 1 will cut, that will become 4x, that will be 2x plus 2x, that will be 4x by 4, and that is simply x. That means BD square is equals to x. From here you can write that, where to write? Okay, we will cover just this one. This implies that BD is equals to root of x, isn't it? Okay, so BD equals to root of x, and here BD equals to root of x. So, by this kind of construction, can we assure that the value of this BD will be always equals to root x, right? Now, you can measure that root x, particularly BD, and draw it in the number line, your number line. Okay. So, just now note this completely and then we will move forward. Okay. So, noted it completely. Students, this is for today. Okay. Now, we have gone through the identities and we have covered this particular method of representation of the irrational numbers on number line, irrespective its root 2, root 3 or maybe root 11 or root 32.7 or maybe 1.222, like that values we can cover by this method. In our next lecture, we will do the multiplication, division, addition, subtraction of irrational numbers with the help of the identities we have discussed in today's lecture and the day before today's lecture, that means yesterday. Okay. So, in our 2 lectures, we have covered the identities and we will do the question, but in our next lecture. Okay. Till then, take care and have good study. Bye bye.